Hello, let's do a regression analysis using SPSS and JASP, and the data file we are using is called D2. So this is our data set. I have these four variables are all continuous variables. They are not categorical variables. And specifically for regression analysis, you need continuous variables generally. By the way, this is not real research data, so you cannot draw any conclusions based on the results of this analysis. So it's just practice data. So I choose happiness as our outcome or dependent variable. And three variables: social support, quality of life, and extroversion. These are supposed to be our predictors, independent variables. So I'm going to use three variables to predict happiness. And that's where I need to run a regression analysis. Analyze regression linear. So you send happiness to dependent variable box, and you select your predictors and you send them to independent variable box here. And let's click on statistics. In particular, confidence intervals are recommended. So let's get confidence intervals. And also collinearity diagnostics. So just tick this one, and then click on continue. Then click OK. And here are the results. You get a couple of tables here. Let's start with this table, where you get your R-square, which is a very important number for you. So R-square tells you how much your predictors are explaining. So in this case, our R-square is 0.60. So you can say that your three predictors together, collectively, explain about 60% of the variance in happiness, your outcome. So this is what R-square tells you. And it's very important because we want this number to be big. For example, if your variables, three variables together, they explain about 1 or 2% of the variance in happiness, then you say that these predictors are not very good predictors of happiness. But 60% is very high. So we can say that in general, we have very good predictors here together. Still, we don't know which predictor is better than the other one. We just know that together, they are predicting a large portion of the variance in happiness. Also, you get adjusted R-square, which is usually very similar to your R-square. It's just an adjustment to your R-square based on your sample size and the number of predictors. So everything equal, if you have more predictors and less smaller sample size, the bigger the adjustment. So your adjusted R-square becomes smaller than your R-square. In this case, we have a reasonable sample size and only three predictors, so they're very similar to each other. It's good to report both of them. ANOVA table. This one presents an F-test, which is related to your R-square. Basically, you want to know if your R-square, this amount of variance explained, if it is significant or not. So here you have an F-test and degrees of freedom, 3 and 124. And this is your F value, and this is your significance level. In this case, it's smaller than 0.05. So you can say that your regression is significant. So this R-square value is significant, which is good news. You want it to be significant. This means that a significant amount of variance in happiness is explained by your predictors collectively together. You have three predictors in this model: social support, quality of life, and extroversion. First thing here is the p-values, unstandardized regression coefficients, but they don't tell you much really because they are unstandardized, so you cannot compare them. You look at standardized regression coefficients or beta weights or beta coefficients, and here you can actually compare the importance of your predictors. Which one is more important? Which one is less important? Here you see that the highest coefficient is for extraversion. So extraversion is your best predictor. Then you see quality of life comes in the second place. So quality of life is also a relatively good predictor, but is in the second place. What about social support? Here you see that it's substantially smaller, this value, substantially smaller than other predictors. So you know that social support is your weakest predictor. And there's a t-value associated with your unstandardized regression coefficients. And then there's a significance level. Here you can say which variables are significant predictors and which one are not significant predictors. As you can see, extraversion, the p-value is smaller than 0.05, so it's a significant predictor. Quality of life, a significant predictor. Social support, p-value is greater than 0.05, so social support is not a significant predictor of happiness. There's also a confidence interval associated with each of your unstandardized regression coefficients. And here, for example, you see there's no zero in this interval for quality of life. So quality of life is a significant predictor. Collinearity statistics, these are to make sure that your regression equation is healthy. And this is one of the assumptions of regression analysis. There should be no collinearity, multi-collinearity between your predictors. Basically, it means that your predictors should not have a very high correlation between themselves. If the tolerance value is smaller than 0.2, you can conclude that there is a problem of collinearity for that predictor. Here, fortunately, we are lucky, and our tolerance values are not smaller than 0.2. Some books mention 0.1 and some books 0.3. So it should be around these values. So please check your reference book for making the final decision. For VIF also, 10 is recommended. If your VIF value is greater than 10, then you can conclude that there is a serious problem of multicollinearity. But other sources mention other values. Let me tell you a little bit more about the possibilities. Analyze regression linear. Another type of predictor that you can include in your regression analysis is a dummy variable. A dummy variable is a variable that has only two values, and one of them is coded 0, and one of them is coded 1. So you can, in addition to continuous variables, you can also include a dummy variable in your regression analysis. I have one here, sex. This one is 0 for female and 1 for male. So I can include it in the regression analysis. You may have different types of coding, such as 1, 2, 2, 3, different types of coding, but the easiest way when it comes to interpreting your results is to use a dummy coded variable 0, 1. And let's see what we get. So this time you see that R-square is slightly increased, only slightly. And our F value is significant. And significance levels related to the other three predictors are almost the same as the previous one. What about sex? Sex is not a significant predictor, and its beta value is small but slightly bigger than social support. So you remember that we coded this as 0, 1, 0 for female and 1 for male. So basically, this means that males do not have higher happiness than females. How can we report our regression analysis in APA style? First of all, you need to report your F value. Your F value is here. So this is the template for reporting your F value. So F value goes here. And 2 degrees of freedom, 3 and 124. 3 and 124 go here. And this is your p-value, which in this case is smaller than 0.001. So you change it to p smaller than 0.001. And then this table is very important. You have to report it in APA style, plus your R-square and adjusted R-square. Your paragraph reporting this regression analysis. So happiness was regressed on social support, quality of life, extroversion. Then you report your F value, degrees of freedom here, your F value, and your P value. Here, you have to also comment on your collinearity situation. And in this case, because all our tolerance estimates were smaller, bigger than 0.7, so they were not smaller than 0.2 or 0.1, then we can say that there was no serious problem with multicollinearity, and that's good news. Then you talk about your R-square. The model explains about 60% of the variance in happiness. So you are basically reporting your R-square here. Also, it's a good idea to report adjusted R-square, which is next to your R-square. Just take it from here. And then you provide this table, but you need to change it, format it in APA style. So table 1 gives information about regression coefficients, and you provide the confidence intervals as well. And here you mentioned that quality of life and extroversion were significant predictors, but social support was not significant predictor. Now let's do it in JASP. In JASP, you need to go to regression and linear regression. It's pretty much like SPSS. You send happiness here, you send your 3 predictors to the covariates box. And that's it. You can get you can go to statistics and get confidence intervals and collinearity diagnostics again. And the results are pretty much the same as the SPSS results.